Hey, it's Mr. Allred. We're trying to write vectors in polar form, and more specifically, we're trying to write the velocity and acceleration vectors and combinations of the unit radius and unit theta vector for polar form. So the problem we have here is number 5 on page 787. And the polar function or polar equation we have is r equals e to the a theta. And they also tell us that the d theta dt is 2. So that implies that theta is a function of t. Okay. So r is based off of theta and theta is based off of t. So the root variable in all this is t that we never really see, but most vectors are written in terms of a variable t. But let's see here. The velocity vector requires us to have r prime. Okay, so let's come over to the side, and if we know that r is e to the a theta, then just a small little chain rule here. R prime equals a e to the a theta. So a little chain rule where the u is a theta, and derivative of that is a, comes out front. So let's see here. This velocity vector will be r prime, which we just said was a e to the a theta, times the unit radius vector plus the original r, which was e to the a theta, times theta. That is supposed to be theta prime, I believe. Yes, let me fix that. Sorry. So that means I should have a 2 here, which I could bring out front. But that'll be times the unit theta vector. Okay, so that's our velocity vector. Now when we go down to the acceleration vector, we need r double prime. So we just found the first derivative of r, so the second derivative will be a squared e to the a theta. And up here up top, we had basically theta prime to be 2. The second derivative of that would be 0. So let's see where that takes us. So filling in the acceleration vector, we will have r double prime, which is a squared e to the a theta, minus r, which is e to the a theta, and times the derivative of theta squared. So derivative of theta squared would be 4, since the derivative of theta is 2. So that'd be minus 4 e to the a theta. So this is here, and that's there. So that has the unit radius vector attached to it. And then we're going to add to it, and I'll come to the next line since I ran out of room last time. But r, which was e to the a theta, times the second derivative of theta, which would be 0. So I can just mark all that part out, plus 2 r prime was a e to the a theta, times the derivative of theta, which was 2 again. So you could definitely make that 2 times 2, 4. I'm not because of room. But then that's times the unit theta vector. So that whole bottom part there is the acceleration vector. All right, good stuff.